Okay, let's take a closer look at the double angle formula for cosine. Okay, that's sort of a special one. So cosine of 2 theta, what does that equal? Well, what that equals is cosine squared theta minus sine squared theta. Now, of course, what we do have at our disposal also is the Pythagorean identity, which says that sine squared theta squared plus cosine squared theta equals 1. Now, so what I could do here actually is get rid of that cosine squared by just solving this and seeing that sine squared theta equals 1 minus cosine squared theta. So this sine squared theta I could get rid of by replacing it by its twin, 1 minus cosine squared theta. And if I do that, what do I see? Well, let's actually try that. Well, I still have that cosine squared theta way out in front, but now I have to subtract off this. So I've got to subtract off everything now. So I'm going to subtract off everything. 1 minus cosine squared theta. So if I do that, what do I see? I see cosine squared theta minus a minus becomes a plus another cosine squared theta. So I see 2 cosine squared theta and then minus 1. So I see sort of a neat fact. What I see is that cosine 2 theta equals, 2 cosine squared theta minus 1. Now I could have gone back here, and instead of solving for sine, I could have solved for cosine here, and see that cosine 2 theta equals 1 minus sine squared theta. I'm sorry, cosine squared theta equals 1 minus sine squared theta. And then in place of this cosine squared theta, I'd put this in, and if I insert that, I'd see something that looks similar to this. What I would see is cosine of 2 theta equals, what would it be here? 1 minus 2 sine squared theta. So I see these two facts here. Now the interesting thing about these two facts is, well, I can solve this for cosine squared. Let me solve this for cosine squared. So if I solve this for cosine squared, what would I see? I would see, well, I'd bring the 1 over to this side, and so I'd see cosine 2 theta plus 1 equals 2 cosine squared theta. And so then what does cosine squared theta equal? It equals cosine 2 theta plus 1 all divided by 2. So I now see that if I have a cosine squared theta, that actually equals this thing in terms of cosine 2 theta. So if my goal was to reduce the power on cosine, I could take cosine squared theta and make it just cosine theta, and cosine, and the price I have to pay is I change the theta to a 2 theta using this formula. So this is sort of this is called a reducing powers type of formula. If I were to take this thing here and solve for sine squared, what would I see? I would see cosine 2 theta minus 1, and then I have to divide everything through by negative 2. And so what would I see there? There I would see 1 minus cosine 2 theta divided by 2. So if I take this expression and solve for sine squared, I would see 1 minus cosine 2 theta over 2. So let me put these formulas here. They just came from those double angles, and what I see is that cosine squared theta equals 1 plus cosine of 2 theta, all divided by 2. And solving the other equation, which I didn't do, but you can just do it yourself, we get sine squared theta equals 1 minus cosine of 2 theta, divided by 2. So these allow us to reduce the powers of expressions when they get out of hand. Let me illustrate this with a little example. Suppose I want to look at sine to the 4th of theta. How can I reduce that? Well, what I could notice is this is just sine squared theta all squared. Now what's sine squared theta? Well, sine squared theta, I can reduce that just to this. So I can write that as 1 minus cosine 2 theta divided by 2 all squared. Okay? So look what I'm doing. Suppose I want to figure out sine to the fourth of theta. So sine theta to the fourth. How do I do that? Well, one thing I could do is sort of reduce the power. Now it's cosine stuff, and I only have a squared, you see? I ate the other thing up inside here now. But what does that equal? Well, the denominator squared is just a fourth, so this equals 1/4 out in front. And now I've got to square that out. Now remember, it's not just 1 squared minus cosine squared to theta. I've got to FOIL. So if we FOIL carefully, I think what we see is a 1, and then minus 2 cosine 2 theta. I'm foiling in my head. And then plus, last times the last, cosine squared 2 theta. Okay, fine, but still I've got a term here to the squared power. I can get rid of that using this formula. So in place of cosine squared blop, I'm going to use this formula right here. Notice there's going to be a little tricky thing here. Now in place of theta, I have a 2 theta. So when I plug in 2 theta right for theta, I'll see 2 theta times 2 give me a 4 theta here. So you have to be a little bit careful here. But if we use that formula, what I see is the following. I would see this equals 1/4 1 minus 2 cosine 2 theta, and then plus, and then what do I have? Well, using this formula right here, what I would see is a 1 plus cosine, now I have to be really careful here, 2 times this angle. Well, that angle is 2 theta, so 2 times that is 4 theta, all divided by 2. And now, well, I could simplify this a little teeny bit by getting everything over a common denominator. So I put this 4 over 2. This is 2 over 1, so it's 4 over 2. And this would be 2 over 2. And if I do that, what I think I'd see is the following. Let's see if I can just keep a little piece of that right up here. Well, you probably can't see that. So let me just write it out here. So what I would see is 1/4 times, and now everything is going to be over 2. So I have a 2 minus 4 cosine 2 theta plus 1 plus cosine 4 theta, and that's all divided by 2. I just got a common denominator. That 2 can be pulled out here, and I see 1/8. 2 plus 1 is 3, and I have 3 minus 4 cosine 2 theta plus cosine 4 theta. Now you might think, oh, I can combine these things. But no, I can't. This is cosine 2 thetas. This is cosine 4 thetas. They cannot be combined. But the really amazing thing is that the original question was, what is sine to the 4th theta equal to? And it turns out that I was able, using these two reduction formulas, I was able to use these twice to reduce this thing, this sine a theta all to the 4th power, all the way down to something, I admit sort of complicated now, but there's no powers at all. It's just, in this case, just cosines. A whole bunch of cosines running around to no powers at all. So if you knew how to find the cosine of angles, but not how to take powers, for example, you can reduce the simplicity down to something that has a lot more terms, but no powers. So that's the power of this power reducing stuff, where you can actually reduce the powers. If you have trig functions to high powers, you can just use this sort of technique to shrink those down. Of course, it gets longer, but now no powers. Look, Ma, no powers. Anyway, try some of these power reducing things yourself and see if you can sort of slowly and carefully, be careful of the 4th theta here, reduce the powers yourself. I'll see you soon.